Good morning, everyone. Welcome to What's New in Support Library. I'm Alan Viverette. I'm tech lead for the Android Support Library team.
I'm Clara Bellarri. I'm a tech lead on the Android UI Toolkit team.
And we're going to be talking about what's new in Support Library from 25.3 through today's release, 26.0 Beta 1. So has anybody here not used the Support Library to develop an Android app?
Oh, wow.
One person. Do you actually develop Android apps? OK, so everybody here is pretty familiar with the Support Library. It's a collection of utilities and classes that make it easy to target older versions of the platform, use some new concepts like material design widgets, and it's a very essential part of Android app development. So we're going to start by talking about what's old in the Android Support Library before we move on to what's new. So last year, you may recall that we dropped support for SDKs lower than 9. So Donut, Eclair, and Froyo went away. And this allowed us to focus more on the API levels that developers are actually targeting. So a lot of compat code went away, and we reduced our method count by quite a bit. And when you're targeting platforms earlier than 21, you're worried about the 65K DEX limit, this is really helpful. So today, we have fewer than 1% of active Android devices, according to Play Store check-ins, on APIs lower than 14. So you may guess what I'm about to say. Is anybody still targeting Gingerbread? One or two people. You probably have a sinking feeling right now. So as you might have guessed, we are removing support for APIs lower than 14. And the Support Library team is as happy about that as you are. So we've got some great benefits from this. But the main thing is that if your min SDK is not already 14, it will become 14. If you're still targeting older versions, the 3 of you in this room that are still targeting Gingerbread, you can still use the existing versions of Support Library. So 25.3 is going to continue to work on Gingerbread and Honeycomb. But if you want to use some of the new features that we're talking about today, you'll need to maybe have a separate code branch where your min SDK is 14. All right, so some of the benefits that you're going to get from this. We've dropped over 1,400 methods. So we're a little bit backing off from the DEX limit. And we're going to be removing even more classes and methods. So just public methods and classes and interfaces. We're deprecating 30 classes, over 400 methods that are no longer necessary because they're compat wrappers for APIs that actually exist on 14 and above. So for example, viewcompat.setPivotX is now going to show up as deprecated. And you can replace that with a call to the actual setPivotX method, because that exists. There are some methods where we have workarounds for bugs in existing versions. So it may still be useful to be calling viewcompat. But anywhere that's been deprecated, you can go ahead and migrate away from. And we'll be removing those methods in a later version. All right, so we've made it easier to develop with the Android Support Library. We're also going to be improving the way that you get the Android Support Library. We've modernized our distribution method and added the Google Maven repository. So every time we update the support library with a bug fix, you don't have to download 500 megabytes of internal Maven repository. We're including support library as well as constraint layout, the application architecture components that you may have heard about yesterday. Through this Maven repository, we're including every historical version of support library, including 26 Beta 1, which is only available through the Google Maven repo. So you can go ahead and make this transition even if you're not targeting 26 yet. And it's as simple as just adding the Google Maven repository to your Maven repositories in your build.gradle, and then everything else continues as usual. So you just set up your compile dependencies, and you're good to go. And just a moment while a bunch of people take photos. The slides will be available later, so any links that we're showing, you can look at later. All right. So we've made it easier to obtain the support library. We've made it easier to develop with the support library. We also want to make it easier to develop the support library itself. So we're improving workflow with our issue tracker. We've moved from Google Code to our new issuetracker.google.com. And this is providing a much, much better tool for us to track bugs, manage hot lists, and respond to you and let you know that we're following up on what you're telling us about bugs. But this is also better for you. It's more stable, and this is going to provide a faster response time when you file bugs. But thank you. So when you file a bug, sometimes maybe we're slow to respond. We try hard, but there are a lot of bugs. So if you decide that you want to handle a bug yourself, we have support for developing support library from AOSP in Android Studio. So if you check out our minimal branch of AOSP, an unbundled support library branch that is, I think, around 6 gigs right now instead of the full 150 gig Android checkout, you can open the framework support root in Android Studio. Everything works. You don't have a bunch of weird red arrow lines. If you tried to develop Android Studio, AOSP code, framework code in IntelliJ, you've probably had a rough time, but we have vastly streamlined the experience for developing support library. And we want to get patches from you. So we have a guideline for external contributions now available on android.googlesource.com in the framework support section. So if you send us a pull request, you send us a Gerrit CL review for bug fixes only right now. We're not taking API changes. For bug fixes, we'll look at those, we'll give you feedback, and hopefully we'll be able to integrate those into our main repository. All right, and now over to Clara to talk about some of the actual new features.
Thank you, Alan. It's an exciting year for text. We have 4 main features that we're presenting today. They're in Android O, and they're all in the Support Library 26 Beta 1. Let me start. The first feature I want to present today, we're calling it Fonts in XML. If you've ever tried to use a custom font in your app, you might be familiar with a painful process that looks something like this. You create your custom text view. You load your typeface. Well, you get it from the typeface APIs, you load it onto yourself, and then the worst part, you use your custom typeface everywhere in your XMLs. That's not fun. We've seen some more clever ideas out there, like people using data binding to solve this, but we decided to fix this in the framework. So starting now, fonts are a new resource type. We have created, thank you. You can now put all of your font files into the res/font folder. We will be taking care of creating IDs for you. We are also adding support for font families. Font families are when you have more than one file to define a font. So for example, you have a regular, a bold, an italic, and a bold italic file, and you want to treat those as a unit. We are adding support for that as well. So we've defined new XML attributes. You can define an XML with a font family tag and font tags for each of your fonts in the family. You can see here I've defined a family with a regular and a bold font. Creating this, you tell us what the style and the weight is for each of the files. And then this, for example, would generate r.font.myfont. This is a family. It can be used as a unit, and everywhere the framework will take care of selecting the font it wants from that group. So you may be familiar with the Android font family attribute in TextView. This has existed since way before. It takes strings, so it takes things like sans serif, cursive, or monospace. Well, we've extended it now to take font resources. So you can now say Android font family at font my font, and it just works. We've also added support, obviously, for text styles. So text style already existed. If my font here were a family and you tell us to use bold, we will automatically use the bold font within your family. This also applies to text spans. So if you're using spans within your text to define different styles, we will automatically select the font for you and take care of everything. As you can imagine, it also works with styles. Just define it in your style, set it on your text view. Everything works. And if you want your resource from code, we've added resources_compat.getFont. Just give us the ID. We'll give you a typeface back. This is all available to you today on APIs 14 and above, thanks to the support library. Thank you. So let me move on to another fonts feature. We have downloadable fonts. We noticed that lots of you bundle fonts into your APK, and fonts are really large files. Even more, like you are probably bundling fonts that are not even optimized for mobile. And it turns out that Android doesn't need about 50% of the file. We don't need it for mobile, but you are still bundling it into your app. We made a little analysis, and we found that the top 25 apps on the Play Store that do bundle fonts are bundling an average about 500K in fonts that we have in the Google Fonts catalog. Couldn't we do better with that? Also, never to mention the fact that you are bundling the same font in several different apps, and the user is downloading this font over and over again. So this is where downloadable fonts comes into place. We've created the concept of a font provider. And a font provider is the separate entity that is not your app, and its own mission is to fetch fonts, cache them, and serve them to you and to every other app that wants fonts. So then hopefully you can get rid of your bundled fonts and just rely on a font provider to give you all the fonts you want. The way this works is all apps can access a font provider via the Fonts Contract Compat APIs. This means that you all have one entry point into the font provider. The benefits of this are, oh, sorry, can you go back one? Benefits of this is we have one copy of the font. We only have one copy of the font on memory, saving memory for the user. We have one copy on the device, one copy so that you don't have to bundle it in your APK, and we're only downloading it once from the network if you were also downloading it yourself. We're very proud to announce that our very first font provider available today to you is a collaboration with the Google Fonts team. We are providing the entire Google Fonts catalog through Google Play services so that your app can use all of the Google fonts. That is more than 800 fonts just out there for you. Thank you. The way this works in code is you need to create a font request. That just tells us what font you want. So you will give us an authority and a package for the provider. The actual query of the font, so say you want Comic Sans maybe, and then the array of certificates that the provider is signed with. This is very important. Fonts are kind of a security loophole. They can load code, and they can execute code. So we want to make sure you have a trust relationship with your font provider. You don't want to be loading fonts from anywhere. For example, we can ensure you that all the Google fonts available in Google Play services, we have verified them. We know they are secure, and we know they are mobile optimized. Next, you will create a callback, and the callback has two main functions. One for when the typeface is successfully retrieved, and one for when there's a failure and what the failure was. Once you have these two components, you will call fonts contract compat.requestFont, and that just takes a context, the request and the callback that you just generated, and a handler. Requesting fonts may take some time. We are making a connection into a font provider, so we want to make sure that you have control over where this is executed. Please do not give us a UI thread handler. We may block your UI thread. So it's all under your control. Because I just talked of fonts in XML, isn't it obvious that we tied these two together? You can obviously specify your downloaded fonts in XML. We've added 4 attributes to the font family tag for the authority, package, query, and certificates. This is equivalent to creating a font request. You specify it in XML, use it in all of your layouts, and we will take care of fetching the font and displaying it for you. Obviously, if the font takes too long, we may time out and render in the default system fonts, so bear that in mind. Next, I want to show you the Android Studio team have done a great collaboration with us. As you can see, I have a text view here. If you open the properties in Android Studio, you will see there's a font family section. Usually, it takes things like sans serif, cursive, monospace. Now, if you open it, there you go, and you scroll all the way to the bottom, there is a More Fonts option. That opens the new Font Picker. Font Picker will show you fonts that are already in your project, because you've bundled them, fonts that are in the Android system, and downloadable fonts. Right now, you may notice on the top right, the source says Google Fonts. We are ready to integrate with any other font provider that comes out. Right now, it shows all of Google Fonts. So if you scroll a bit, you will see that is the entire catalog. Right now, I want to search for a font. So for example, Pacifico is one of my favorite fonts. So I will search for it, select it, just hit OK. Android Studio generates all of the XML for me, and even pre-renders it to show me what it will look like. Thank you. Notice that we opened the XML that it generated the 4 attributes we needed, and all of the certificates needed for Google Play services, all for free. If you want to know more about the Android Studio, go check out what's new in Android development tools. It's today at 11:30 in the amphitheater. For more information on downloadable fonts, we do have a sample app that is published on GitHub since yesterday. We have public documentation that you can access Again, the slides will be available later, so don't worry about the links. We have Google Fonts documentation that will tell you how to use the Google Fonts font provider specifically. And the one caveat to use the Google Fonts, because we've done it an integration in Google Play Services v11, that is not out to the public just yet, but you can join their beta through that link over there and get v11 so that you can play around with it as a developer until it actually rolls out. Downloadable fonts available to everyone, API 14 and above. Thanks. Next, let's talk about emoji. Have you ever seen one of these boxes with a cross in the middle? We call this tofu, and it's what we render when we can't render a glyph you've asked for. This is extremely common in emoji. Every year, the Unicode defines more emojis, and it turns out that our emoji font is bundled in your system, so we can't actually update it. We can't actually give you all of these new emojis. So you start seeing these. Maybe you, with a new device, will send an emoji to your friend who has a KitKat device. They will never actually see that emoji, and that's really bad. So we've decided to fix this. The Emoji Compatibility Library is a support library that has access to a newer emoji font. So what we do is for each emoji that you're trying to render, we check if the system font can render it. If so, we just leave it at B. If it can't, we substitute it what we call an emoji span. And that means that we can use our available emoji font to actually render that for you. There are two ways to use the Emoji Compatibility Library. You can either bundle the font into your app, or you can let us use downloadable fonts to actually get the latest emoji font for you from Google Play Services and Google Fonts. So to look at this, when you want to use a downloaded configuration, you will use a support emoji dependency. You will then create a font request, which we've just seen in downloadable fonts. You will be able to get these values from Google Play Services and Google Fonts to actually use their emoji font. And then you initialize emoji compat with a font request emoji compat config. And this just tells it to go find the downloaded font. If you do this in your application on Create, then you're set. If you say, oh, but I actually target non-Google Play Services devices, I can't use this, that's fine. We have the bundled configuration for you. You use a different dependency. You use support emoji bundled dependency. And what that does is it pulls the latest font we have at that moment into your APK. Do note that font is about 7 megabytes. So be careful with this. And of course, once you've shipped your app, it will not get updated. So it's up to you to ship a new update on your app to get the newer fonts. To do this, extremely easy. You create a bundled emoji compat config, set it initialized on emoji compat, and you're set. Then to actually use the emojis in your app, we've provided some widgets for you. So we have emoji text view, emoji edit text, and emoji button. These automatically use emoji compat, render all of the emojis for you. Some of you might say, oh, but I have my custom class. I don't want to use this one or extend this one. I have my own thing. Go read the documentation. We have very detailed steps on how to integrate emoji compat into your own custom class as well. Hopefully, you will stop seeing tofu, especially if you're something like a messaging app. This is really important to you. You will start showing emojis to your users. Again, some links. We have a sample app. It's available on GitHub. We have public documentation on how to use this. And because if you use the downloaded configuration, you are using downloadable fonts, it has the same caveat. We need Google Play Services v11 beta. So please sign up to the beta to play around with that. This is available to everyone, APIs 19 and above. Finally, I want to present our fourth and important feature. We've made text view auto-sizing. What this means is you might have run into this case where you have some text, you've carefully measured your text view, you know your text fits, and then your translations come around, and they're longer, and they don't fit, and you start seeing that your text doesn't fit into its bounds. Well, that's where auto-sizing can help you. What we do with auto-sizing is we choose the size of the text depending on the boundaries of the text view. So as you can see, we will increase your text size as needed to fill in its container. Using this is really, really simple. You use this auto-size text type attribute on text view and set it to uniform. What this will do is it will scale the text both in X and Y axis uniformly. Some of you may say, oh, but I need more control. I can't just let my text be any size. My UX people would kill me. That's fine. We have more control for you. You may give us either an array of preset sizes, in which case we will take the best match out of the sizes you give us for the given boundaries, or you can give us a minimum, a maximum size, and a step or granularity. What we do with this is, for example, in this case, you say from 12 to 100 in steps of 2. We will take values such as 12, 14, 16, 18, and so on. and we will snap only to those sizes. Auto-sizing text view is available to you today in Support Library for APIs 14 and above. Now let me hand it back to Alan to talk about animations.
Right, so now that we've made our apps beautiful by switching everything over to Comic Sans and adding new emoji, let's also make our animations beautiful. So Support Library 26 adds a number of backwards compatible improvements to graphics and animations. And first among these is dynamic animation. So this is going to be a library for direct interaction and animations in response to that. So these are based on velocity instead of duration. You may have had an animation where a user touches the screen, drags something down, and the touch has some sense of velocity. So you want to fling something off the screen, and you want the velocity to match their initial touch movement. And you can run those calculations, and you can figure out an interpolation curve that's going to roughly match what they were doing before the animation started. But it can be a lot of work. So dynamic animation is going to help you create natural-looking animations in response to direct user interaction. We've provided two animations right now, spring animation and fling animation. And these are respectively for behavior where you want to drag something down and maybe it snaps back and eventually reaches an equilibrium point. Or maybe you grab something and you fling it off the screen and you want it to slow down as though there's friction. So what that looks like in practice is I have an Android view, a Bugdroid view, and I touch it. And as I'm pulling it down, we start feeding touch events into a velocity tracker. So this knows how fast the Bugdroid is going to be moving when I let go of it. As I'm moving it down, we're tracking the Y translation so that it follows my finger. And when I remove my finger, we're going to start our dynamic animation, our spring animation, on our Bugdroid view. So from code, that looks like this. We're creating a new spring animation on our Bugdroid view. We're going to be animating the translation Y, the vertical translation that we've been using to track our user interaction. And when I let go of that, I want it to return to an equilibrium state of 0 translation Y. So when it springs up, it's going to overshoot, and eventually it's going to settle on 0 translation Y as equilibrium. Spring animation uses physical properties of springs. So the damping ratio is how quickly the spring is going to come to rest. A damping ratio of 0 would oscillate infinitely. A very high damping ratio will stop animating very quickly. Stiffness is how quickly the spring is going to snap back. So a very high stiffness, when I pull the spring down, it's going to snap back immediately. A very low stiffness would be like a car with a loose suspension. It's going to just bounce back and forth slowly. All right. Finally, I want to pull in the velocity that I've been tracking. This is the direct interaction portion. So I pull it down very quickly. When I lift my finger up, I want it to keep moving with that energy. If I move my finger very slowly, I'm going to lift my finger up, and I want it to start moving back, because there's very little energy that my finger is putting into it. Then finally, we start our animation, and we end up with an Android that snaps back, springs a little bit, and eventually comes to rest at equilibrium. If you want to learn more about dynamic animations, you can check out Android Animations Spring to Life. That'll be tomorrow at 2:30, stage 2 right here. We've also made some improvements to drawing with vector drawables. We've added feature parity with fill type. So fill type, if you've ever received an asset from UX that has hollow areas in the middle. So here we have a light bulb that has a single path defining the entire area, and it has some empty areas. So this looks great in Photoshop when our designer exports it. This looks great in Asset Studio, which is rendering as though you're on the latest platform. But once you load it onto a device running API lower than 24, you see that there's some weird artifacting at the edges. And the reasoning for that is the format of SVG that gets exported by our tool, in this case Photoshop, uses a fill rule. And this defines what the inside of our vector path is. So you'll notice we have a single path that defines our light bulb. We have a rule that tells the renderer which is inside fill and which is outside fill, which is transparent. So this was added in the framework in API 24, and we've now backported it to API 14. So the assets that you're using, generating from Android Studio, the assets that your designers are generating from Photoshop, you can just use across all supported APIs. So you write one XML, and it looks correct across all platforms. Nobody has to go and hand edit things so that you can use a single fill rule. Right. Speaking of vectors and parity, we're adding parity for the ability to morph between different paths and interpolate along a path for animated vector drawable compat. So again, these are some new features on the platform that we're backporting to API 14. You'll be using the same XML on API 24, API 26 that you would on API 14. And here, for path data morphing, we're going to be able to take an initial path spec, so the long string of numbers and letters and commas that you may see if you actually dive down into your vector drawable paths. One caveat here is the path formats must match. And this is something that can be handled by tools. We use Alex Loxwood's Shapeshifter tool for this demo that we're about to show. So here's what path morphing looks like on a device. A very common case of morphing from a buffalo to a hippo to an elephant that I'm sure you're all familiar with in your Android apps. All right, so let's look at what's going on at the XML level. We have vector drawable defining our starting image, a buffalo. And here I've extracted out our path data for the buffalo. So that long string of letters and numbers that defines our vector path, I pulled out into a string resource. And we're going to be reusing it in our animation. And this also just makes things way more readable. So we have our starting vector XML that we want to animate from. And we have our object animator. Now, the new thing here for API 14 and above is the ability to specify path data as your property type. So we're going to animate the value from our buffalo path spec to our hippo path spec. And this is actually going to transform the points and give us that morphing animation that we saw. We pull this all together into an animated vector, which points the drawable to our starting buffalo. The target, we're taking our buffalo path from that drawable, and we're going to be morphing the path data from a buffalo to a hippo. So we're going to take this a little bit further and take advantage of a feature in AAPT to use a bundled XML format. So you may not have used this before, but it's really cool. This is supported on through AAPT, so it's backwards compatible. We're going to take this, and we're going to take our drawable and expand that out into an attr element. And this replaces the Android drawable attribute in our animated vector element. And we're going to inline our initial drawable, our buffalo vector drawable XML in this element. So now we've gotten rid of our buffalo.xml, and we've centralized things in our animal morph bundle.xml. So if you're not reusing buffalo.xml, you just need it for this animation, it can really simplify and clean up your resources directory. We're going to do the same thing with our animation. And now we have everything neatly contained in one file. So the only thing that we're going to reference from our layout XML or reference from code is our animal morph bundle drawable. And we don't need to keep a separate animation XML in some other resources folder somewhere. If we're trying to send assets between developers or from designers to developers and vice versa, we don't have to bundle everything into a zip and then tell everyone, OK, this goes in the anim directory, this goes in. Everything is one file. Very clean, supported all the way down to API 14 through AAPT. Right. We've also backported support for interpolation along a path. So this provides parity with the platform AVD again. And this is going to allow you to set the interpolator on your object animators to be a path using a spec similar to what you would use for SVG and what we support in vector drawable path data. So here's an example of combined path morphing and path interpolation. This one's pretty complicated, so we're going to take a slightly more simple example to break down how it came together. Let's say our UX designer was not feeling particularly creative, and they want us to shrink down a square. But they want it to have an interesting acceleration curve as it's shrinking down. So we're going to shrink down real fast, bounce back a little bit, and then slowly reduce it to a point. So our path interpolator that we use on API 14 through current API 26 is going to look like this. We define our path data as an SVG-like path, a vector drawable path data. And if you render that, it looks like this. So our curve is quickly reducing from 1.0. We're bouncing back a little bit, and then we're slowly tapering off to 0. And this is what you see when it shrinks very quickly, and then gets a little bit larger and shrinks down to 0. It's very easy to use this in our object animator. Again, compatible, same XML for API 14 and 26. We just set our interpolator to be our new path interpolator. Once again, I'm going to pull everything out into an XML bundle because it helps clean things up. And then we get this quick shrink and then a slow fade to 0. All right, so far, all the screenshots and videos that I've shown you are from phones. But Support Library 26 also introduces a number of changes for alternative form factors like watches and TVs. So on the watch side of things, we're integrating the Android Wearable Support Library into the mainline Android Support Library. So what you're going to see is a number of improvements in core UI elements. Things like improved circular scrolling with Wearable Recycler View, better support for responsive layouts on round screens and square screens with Box Inset Layout, and consistent user interaction models from classes like Swipe, Dismiss, Frame Layout. So you can learn more about developing for Wear devices at the Android Wear UI Best Practices talk, which will be at this stage on Friday at 3:30 p.m. tomorrow. We've also made some improvements for developing TV interfaces. So the Leanback library has added Playback Transport Control Glue, which adds a seek interface for videos. And if you're writing an interface for Leanback, this is probably something that was painful to do yourself. So we have a prepackaged seek with preview. And we're also allowing you to embed a video view inside of a detail fragment. So if you're writing something for browsing media, and you want to be able to play that media in line while you're showing people the description of it or the ratings of it, that's now very simple to do with Details Fragment Background Controller. And if you want to learn more about developing for TVs, you already missed the What's New for Android TV talk. However, you can check out their office hours at 6:30 this evening in Section 3. Right, so we have a number of other smaller behavior changes and new classes that I think it's important for everyone to know about in the 26th release of Android Support Library. So first of all, Preference Data Store. For anyone who's storing their preferences in the cloud, you may have had to do something a little tricky if you're using the normal preference fragment and preference manager. So this allows you to customize the way that your put and get calls for preferences are handled. So with the implementation of this, let's say we want to store preferences in the cloud. We'll extend Preference Data Store, the new class, and we'll override here just get Boolean and put Boolean. So when we put a Boolean preference in, we're going to start some asynchronous call that stores it in the cloud. Now, because we want to be able to retrieve a value without having to wait for cloud interaction, we're going to store this locally as well. And an important thing to keep in mind with this class is that calls are going to happen on the main thread. So if you're doing some long transaction, you're doing something in the cloud, you're persisting something to disk, you'll want to do it asynchronously and have some way to handle quick calls after that to get Boolean, so something like local caching. To set this up on our preference fragment, we're just going to grab our preference manager. We're going to set an instance of our preference data store on that. And all subsequent get and put calls to our preferences are going to go through our new preference data store. We also have some changes in Fragment Manager that are important to know about. So transaction calls, things like execute pending transaction, commit now, can be dangerous to call if you're already in a transaction, if you're already in a state change. These can be reentrant and have some unexpected behavior. So we want to make it a little bit easier to do the right thing, more difficult to do the wrong thing. And these will now be strictly enforced and throw exceptions if you're trying to do reentrant transaction calls. And for developers interested in learning about their UI performance, we've added Frame Metrics Aggregator. So this allows you to attach to an activity and get information about rendering milestones during the rendering of the lifecycle of a drawing frame. Now, if you don't know what a rendering milestone is, or you do know and you want to learn more about assessing the performance of your UI, you can check out the Android Performance UI talk. If you don't care about performance of your UI talk, but you saw Chet's talk yesterday, Speechless, and you just really love Chet talks, it has Chet. So you can check that out Friday at 1:30 p.m. on stage 4. And last but not least, this is actually from 25.3 API, but I thought it was really important. So Action Bar Drawer Toggle is this class used to animate or implement the hamburger button, the button that you use to open the navigation drawer, the 3 lines. And you may have noticed in some apps that when you start to pull your drawer out over the hamburger button, it animates. And this is officially not the thing that you're supposed to do, but I see a lot of apps that have done it. I see a lot of apps where it looks like you've probably fixed it. So that looks like this when it's wrong. We pull it, and the hamburger turns just a little bit. Some lettuce is falling out. So you noticed it wasn't quite right. Maybe you fixed it. Maybe the way that you fixed it took a couple hundred lines because it was really difficult to do. Don't do that. Stop that, and instead do this. We now have one line to disable the drawer slide animation and get the correct behavior. So use that. And also check out some of the next talks that we have, some of the talks that we've referenced today. So we have What's New in Android Developer Tools, if you want to learn more about things like the font tool that's integrated into Android Studio, Android Performance UI, if you want to see Chet on stage again, Android Animation Spring to Life for direct interaction, and Android Wear UI best practices for learning how to create UIs optimized for watches. So thanks, everybody.
Thank you.
We'll be around for questions afterwards.